We start on turning on our power supply, turning on the PC. As the PC is on, there's no password, you can just enter. And when the PC is on, we can turn on the rest of the system. Here we plug in the MyRio. When you hear that the MyRio connected, it is important that you shortly after turn on the program. Now we have two screens, and I normally divide the two screens into having my left screen as my camera towards the cantilever. You can do it a bit better in graphic. Here we put in the settings, and then you can zoom directly on the camera. Then you can see that it is far from the sample when you need to take off the lid. On my right screen, I open the program shortly after I have connected the MyRio and it's connected. Then you can shortly see that it will be connected as a green square, and you will get a signal as we see here, and then we can get started. This is our front page of the program. Up here we have the focus area signal. This is a signal measured by the detector from the laser from the cantilever's movement. This can be converted into nanometer measurement image, as we see as the big orange square and the signal down here in the black area. And this can be put onto our left image. We will use this when we navigate around from a large image towards a smaller image. And over here we see that we are on approach side right now. Here we can turn on fast approach, then we can move the cantilever up or the probe down, slowly or fast. We can also do it manually. We can see here the delay and how many steps. We can do it quick here, and we want to quickly move up, so we put a minus in front of our steps, and we then press send steps. Then you can see the movement, and we can press stop motors, and it will stop the movement. So we go in indicators, we don't use that. We go into settings. Here we see how fast the probe move across the sample, and here we are setting max volt ratio between volts and micrometers. Here we see that 2.23 gives a image that is 20.78 times 20.78 micrometers. We want the image to be nearly precisely 10.0, so we will see now how we calibrate it towards that. Some setting for the shake. We do use a shake if we want some movement in the sample. If we have scanned at one area, I want to scan in another area. And now I will go a bit to the right so we can see the rest of the screen. Here we have the shake button where it will shake, and we have a piezo field, which when we apply this, it will gives a constantly shake to the sample holder, and we can use this to navigate ourselves to see whenever we are in contact with the sample by the focus area signal window. Yes, so let's get started. First, we need to find our focal point onto the probe. As we see here, we move a bit on the cantilever. We want it a bit to be in the middle by a blinded spot, and then we can move our Z-axis and our X-axis by two knobs we have on the board. Here we can zoom and move back and forward by the probe. As first I will move back and forward by the x-axis you see here, and it's bound by the blind spot, and then we can move laser up and down, what looks like a zoom on the probe as we zoom in here, and we should be by the focus point as we want. We can press the knob onto the microscope and we will see a cone shape on our signal window. We can also look for an S-curve instead by moving the Z-axis up and down. You will see this on the signal, and then you want to find the linear region of the S-curve, and when you feel like you are in that, you will again check by finding the cone shape on the signal. So now we can calibrate by using a DVD. We here take advantage of knowing the exact measurements and distance in the DVD lines, and want to see how our measured volts can be converted directly to having the right ratio between voltage and nanometers. So first we approach down to our sample. Again, turn on piezo field always when you approach and retract. So we turn our piezo fields to see whenever we are in contact with our sample. You will shortly see how it rises, and then how we see a sinus curve like here, like going up and down, and this shows us that we are in contact with the sample. Always slowly retract a bit. Then we can scan, and we will see how our measurement is the DVD lines down both in the signal and in the window. We want to get a more clear window, so we take a square all over. This will give a more even image between light and dark areas. We can press on mean and move plane, and this will give a more smooth image. Then we want it to be a mirror, like look here in the middle, as we see we move in setting phase shift, and this will allow us that there aren't any bended edges in our image. Then we can calibrate by pressing calibrate, and we will see that 20 micrometers is a 2.06 max voltage, and we can then retract again manually, saying 3 and -10. Then we can use our sample. Here I have made a test sample. I have already removed the DVD, so if you haven't done that, of course you need to do that before you apply the sample. So I have taken off the lids. I take the sample out with a tweezer. And be aware to only have the tweezer on the right area as you hold it, so the rest can be only corner sides. Then you want the sticky part to be going upwards. You can see that by which part that sticks to the tweezer, and you have it nearly centered. You then again apply microscope, and we turn on piezo field. We now want a big image, so we apply voltage to 10, and we go downwards. We send 7,000 steps. That is less than 10,000 steps upwards, so we know that we won't go directly into the sample, but a bit on top of it. The lastly part we will approach manually by pressing the fast approach button, as we do here. And we again look for the smoothly curve and the rise first in the focus area signal window, as we see here. Slowly retract a bit, so we're a bit off, and we can then go scanning. Then we see the signal down in the black area, we see how when it's straight we are scanning tape, and when it has curves we are scanning corner sites. So here we get a image which we call a map image, and we want to save it as a map. So we go in to our documents, we go into AFM, we make a new folder, and the folder we just call test for now for this video. Inside the folder we will have our precisely sample ID as I showed before. This one is called test, and it's from a healthy person. In this case it's a TL0 and it was tape number 2, and the ID we name as number instead, and that was number 1. And we copy because we need to use it later. Then we go into settings and letting the program know that we want to save in this exact folder. Select the folder, then we make a name, we call it map firstly, and then we use Y as a yes for the image and map for Y image 1, and then you put a underline on the end. When you press set cartography, you will see how the large image go to the small image area. We can now move around on the map. First you need to change the setting max voltage to 20 micrometers. Then you can press scan and hopefully get a image nearly the green square that you have set on the map. And you see there is no tape in between of this image. So we save it as image 1 called Y1. In here we see how it's saved. We then open retrace. It gives a way better image when we open it in a scanning probe image processor. Now we open both so we can have them on side of each other. Here we make it a bit lighter and move up and down in nuance to give a not too dark image. And when we find it well, we save it as a JPG in the same folder, as well as map. We also want to save the maps. And when we have saved it as the new JPG, which is way better in details, we delete the previous JPG in the same folder. And that's how we scanned on this specific microscope to get a nano texture image.